Two generations.
Okay. All right, hello everybody. Thanks for joining us for the design feedback for 2023. We are your design event captains. My name is Bill Riley. This is Tony Licio and Edward Kasperzak. So we're going to start out with a few thoughts and observations about the competition this year, and then we'll be announcing the top 3 finalists, and then going through some overall engineering design content for the Formula SAE more generally. All right, well then if we go to the next slide, overall observations and some talking about the fundamentals from this year, we wanted to make a few points. The first was vehicle architecture. It's important to make sure you have a rigorous engineering process around the fundamental vehicle layout. It's really important for the performance as well as the design judging to be able to formulate what your overall approach was to the very fundamental things like mass targets, CG, powertrain, aero, how the aero works with the engine, and then the other suspension parameters to make the car work. We're looking for the design philosophy, and there's no right or wrong philosophy. We're looking to understand how you approach the problem and how you optimized it. Understanding options. So this is a very important point that I wanted to make, which is, not all teams are going to run wings. You might not have the bandwidth, the human resources, or whatever, but we can still have an engineering conversation around it. You can still talk to us about like point sensitivity and how many seconds of lap time you might have gained by having wings or an undertrade. We want to be talking about some of these trade-offs and understand your philosophy and how you're getting to the design you're showing us. Also keep in mind, the fundamentals like load paths. There was still some load paths issues this year. There were rod ends and bending. There was a lot of bolts with too many threads. We might hit on the same topics more later, but just make sure the fundamentals are happening. Be obsessive about mass. I can't tell you how many cars I looked at, and with a hacksaw in about an hour, you could take 1 kilo off by taking all the excessive threads out, or putting fillets and rounds on clevises instead of square corners. So where the stress isn't, the metal shouldn't be there either. Those things, they add up. We always say mass begets mass, so a little bit of mass here, it all adds up. And also it just makes the car look tidy and that you're passionate about excellence. And then another thing we touched on in finals this year, so if you weren't in finals, I wanted to kind of draw it out here, is when we talk about different parts in the car structurally, we're looking at things like the driving loads and the load case. So for example, like what is the driving load in this A-arm? Like where does this force come from? Maybe it's a combination of a bump in a corner with aero load at a certain speed. What is the actual load? And understanding like what's generating that. Also then there's failure modes. So it's like different ways things break. They can break tension, compression, buckling. Composites have many failure modes like interlaminar shear or peel. So make sure you're thinking about load cases, the peak loads, and the failure modes. That will help us have a conversation and vocabulary to be efficient in the design. And also be able to draw and express your designs. Cool to have pre-made cross sections, but on the fly we were asking for cross sections or free body diagrams, and the teams that can just knock that stuff out, it helps us move on to more advanced questions and really helps us dive deep, and that's going to be reflected in your design score. All right, well, with those very fundamental things sort of out of the way, we're going to now announce the 3rd place team for design this year at Formula SAE, which is Purdue West Lafayette, car number 33. Let's give them a big round of applause. And starting out with the table, which is just kind of capture the design of the different vehicles. You can see it came in around 210 kilos with a 51% front weight distribution. Weight is really fundamental. There's no maximum weight to get into finals, but weight really, we weight, you might say, very heavily. It's important to keep the mass down. It's a very fundamental parameter of vehicle design. So we're looking for light cars to be in final design, generally speaking. Now the Purdue car used a 4-cylinder Yamaha running gas. You can see the tires. It was a steel space frame with front rear wings and an under tray. And again, remember, this table is not like the answers. There's a design philosophy that leads the team to these answers. They work for them. But space frames, carbon tubs, wings, no wings, singles, 4 cylinders, there's no right answer. You have to design a holistic, systematic vehicle that works together. Some of the design judge observations, we liked how the wheel speed sensor was integrated with the brake disc. They were able to do hand calcs live with us of the weld margins and had coupon data to support the strengths they were reporting. They did a DFEMA, design failure modes and effects analysis, for the pneumatic system, which led them to putting in a mechanical backup system for looking at reliability. Aero, we thought, was designed to be robust, and they thought about things like yaw sensitivity, not just a single parameter optimization. Good knowledge of vehicle dynamic fundamentals such as cornering stiffness and tire selection. In finals, we had essentially a 5th percentile female and a 95th percentile male to make sure the cars work for a broad range of drivers. And we thought this car really accommodated the 5th percentile female really well. We got good feedback from her. A good understanding of oil pressure and flow requirements for their journal bearings, and they demonstrated an understanding of fuel effects on powertrain cooling. So let's give them one more round of applause to Purdue for 3rd place in design. And in 2nd place, we have Roslaw University Car 131. This car came in around at 203 kilos with a 4-cylinder Honda running gas. It was a hybrid chassis with a composite front monocoque and a rear steel space frame for the engine mount. It also, as you can see, had front rear wings and an under tray. It was a really pretty car, in my opinion, really great build quality, and that really stood out. Had best definition of suspension and chassis targets. Actually, this year I think I saw kind of like setting out the overall vehicle overarching targets and then trying to work and march towards those targets. That's like something I think many teams can take away to work on for next year. Like I said, it had nice fit and finish. The judges really liked the pedals and the feel. They understood the manufacturing impacts on stiffness of the vehicle and those trade-offs. The electronic packaging was well thought out and executed. We were wondering whether it would be difficult to service. Good use of particle image velocimetry to improve their aero design. The ergo judges thought it had good shoulder and knee padding, good driver messaging on the dashboard, the feedback to the driver about how the car is doing. An observation was it had 60% front aero but 51% front weight distribution, so we were struggling to kind of understand exactly how that was working. They had a unique wet sump with a swinging pickup design and excellent validation methodology, including CFD of the inside of the crank. So let's give them another congratulatory round of applause. All right, and our design winner for 2023 is Illinois, car number 19. I will say that the design judges, we were out at the track watching the cars perform and thought Illinois looked really great out there. All 3 of our design finalists, though, looked really great, too. It was great to see them going in so hard. The Illinois car came in at 195 kilos, running a 4-cylinder Yamaha on gasoline. It also had a composite, a hybrid with a front carbon monocoque as well as a rear steel space frame with a full aero package, as you can see there. Some of the judging observations from finals is they had weld data for the lowest margins on the tabs, like the structural attachments. That was good to talk through. They had a really fast, clear, and complete description. We asked them about the way the A-arms are tied into the tub. They were able, like I had said earlier, on the importance of drawing and free bodies and understanding loads and failure modes. They knocked it out of the park on that question with great real-time drawings and discussion. They had detailed hand calcs for the 3-point bend test, which again sort of reinforces the point that design, it's a process. You don't skip right to finite element analysis with a million node nonlinear model. You do a simple hand calc to sort of size out the structures and then get more sophisticated if you need to or if there's a performance reason to do so. They did a visibility study across the different dynamic events to come up with an understanding of how visibility would impact their points analysis. They had a solid use of data for aero validation, including strain gauges to get the loads from the vehicle and testing. Their data drove decision making. We talked to them about Things like how the acceleration data influenced their slip ratio targets. Very strong vehicle dynamics, both in the fundamentals, but also as we dove deeper, they were able to answer our questions. The ergo judges felt like they had the best seat for lateral support of any car in the finals. And lastly, they had knowledge that was spread broadly across many team members and not just narrow silos within a single person. That helps both for obviously more people learning more content, and it also helps with design because people can answer questions and support each other. So let's give Illinois a big round of applause for being our design finalist winner. All right, next, Edward will be talking about some common shortcomings we observed this year.
Okay, so Bill just went through and gave you some highlights of our top 3 finalists. I think the first thing I want to mention before we go into some of the common shortcomings is that, there are no perfect cars. Every single team can improve, including the 3 parked out here that are our top 3 in design finals. And so what we are always trying to do in this competition, whether you're a finalist level team or you just barely got the car built and showed up, is to sort of meet you where you're at and bring you up a notch. Okay, and so in the process of doing that, we do see some trends though, which are worth mentioning to try to bring everybody up a notch. So let's see how many of these things your team has done and how many things on this list your team has avoided. So first of all, know the fundamentals. Okay, if it's in your freshman, sophomore level engineering textbook in the first few chapters, you should just plain know that stuff, okay? It's really of no use if you go and use a fancy software package for CFD or FEA or something and you do not know the basic relationships. And this is a place where some people struggle, and we see this enough to put it as our number 1 on this slide. You got to understand F equals MA, stress-strain relationships, dynamic pressure, the list goes on, all the fundamentals, because it all builds on those. Legacy designs and purchase parts. Okay, no team starts from nothing at the start of a year and then ends up with a car. You are going to have parts on the car that were on last year's car or closely resemble them. You're going to have parts that you purchase that you did not design yourself, did not build yourself, and that's fine. However, we do need and expect you to understand those parts and pieces as if you had designed them yourself. Know what goes into them. If you're not the person that designed your team, if that person graduated, well, you now own that part. You should understand why the part was made that way, what were the trade-offs, what were the compromises, what was the goal, what went into the calculation. Okay, we expect you to own it yourself. And then if you can do that, fine, no problem with those things coming back. The reason we're so picky about that, of course, is this is education, right? We want you to understand what's going into it. It's not good enough just to ride the coattails of someone else or purchase a part and say, okay, we got it, that's done. We really want you to understand what goes into these cars and how all of these things work. Next up, driver interface. How many of you have taken a nap in your car? Good, yes. I mean, if you're unwilling to take a nap in your car seat is not good. Okay, now we're not talking about comfortable, like soft, cushy, comfy, No, we're talking about supportive. When you sit in your car seat, it should be holding you in all the right places with just the right amount. You should feel secure, comfortable, and like you're wearing the car, okay? This is critically important. Same thing with the other two here, access to the pedals and the shifter. If your Achilles tendon is hitting the steering rack cover as you're trying to work the pedals, that's going to get old quick. Okay, you're not going to be focused on driving. If you bump into something trying to get to the shifter, if it's hit or miss, if you can reach the shifter well, that's just going to get in the way. We'll talk about low steering compliance in a minute, but I like to draw the analogy of, say you're going to play soccer and you have a pebble in your shoe. How well are you going to play soccer that day if every time you take a step with your right foot it hurts? Or maybe the pebble's shifting around, you never quite know. If you're driving a car and something's poking you, or you're trying to hold yourself in place because the seat isn't supportive enough, you go around the corner and you're just trying to hang, you don't need to be doing that stuff. You need to be driving the car. And so your interface with the car, how you connect to the pedals, the steering wheel, the seat itself, is super important so that the driver can just drive the car. Okay, so make sure that you're willing to take a nap in your car. It should be like the place that your team fights for, ahead of the crash couch, to just like, it's the best place to be, okay? As far as low steering compliance goes, we also want the car to be responding to the driver's inputs. And so when the driver's trying to make corrections, there should not be a dead spot. The wheel shouldn't be moving fore and aft sideways along with turning. Okay, that's just a bad interface. Really work hard to get that compliance out of the system. Your driver's going to have much better control of the vehicle. Okay, this one's interesting. Suspension kinematics are supposed to be kinematics, not structures. We've seen a lot of very stiff cars where the whole suspension seems to be in the tires, okay? Suspensions are suspensions because they're supposed to allow the tires to move relative to the car, to help control its load as you go over bumps, help to give you the proper load transfer distributions, and make that tire footprint hook up the best you can to the road. I mean, if your suspension is barely moving when we're trying to hop on it, it's probably too stiff, okay? You just really got to get them away from being structures and get the kinematics back in those suspensions. Bill alluded to this one a little bit already. See a lot of threads sticking out the far end of a bolt. They're not connected to anything. They're not doing anything. Why are they there? Okay, you're just giving a little bit of material a ride around in your car. It's adding mass. It's probably getting in the way of you doing maintenance because it's sticking out ready to poke you. Yeah, give us 2 or 3 threads after the nut and you are good. The rest does not need to be there. It's part of properly sizing your connectors. Wiring should be very neat and organized. Okay, we see a lot of cars that have wiring that's just kind of all over the place, weird loops if it is kind of grouped together. Same thing with plumbing, where it's a bit of a maze. Okay, a little bit of time thinking about where your wires go, a little bit of time just cleaning up at the end. One of the things we talk about as design judges is, if I can fix it in an hour, just real quick myself, you should have probably already done it. And so we see a lot of cars that a little bit of a quick fix is all it really needs. A little bit of attention to detail is all it really needs to make it much better and more robust in terms of its lifetime instead of just a bunch of wires. Get them together, bundled, pack it nicely, and it's going to just do a whole lot better, okay? And it's going to look better. It's just better all around. So make sure you pay attention to those details. Okay, Bill's also already harped on you about vehicle mass. Our cars have gotten heavier through the years. While you don't have this perspective, I judged a car that won this competition about 10 years ago that came in at 306 pounds. Okay, so that's something like 140 kilograms. Okay, and the latest car here this year is 160 kilograms. Yeah, I know the rules are a little different. Bigger aero is allowed now. It's not quite an apple to an apple comparison, but the cars have been getting heavier to the point that our average vehicle is 216 kilograms. Okay, let's make it a group effort to get that average down next year. Okay, mass is a first order effect on vehicle performance. It's the M in F equals MA. Okay, it's a big deal. So let's get that out of there. Speaking of aero packages, if your aero package doesn't add downforce primarily by aerodynamics, but does it through gravity, okay, that is not an appropriate use of an aero package. Okay? So think about that. How much does your aero package weigh, and what is the true benefit? So again, in a holistic approach, we do see cars that have this amazing bell crank that's a little spidery connections and very intricate. And next to it is a clevis that's this big block of aluminum that's not even rounded off, and there's this hunk of metal. And it's like, these two things don't go together. So when you're looking to reduce mass, you're not going to chop off, 10 pounds, 15 pounds, 20 pounds, whatever from your car in one place. So it has to be a holistic approach. Go a little bit everywhere, and it'll start coming down pretty quick. Finally, and I'll get back to this one later, validation is essential. So this event, in fact, the engineering process is not about, build it, go fast. It's start with some knowledge, and then create a design, and after you have a design, manufacture it. After you've manufactured it, then, okay, now test it in some way. Does that mean track testing? Sometimes. Does that mean bench testing in some way of your design? Sometimes. Whatever's appropriate for the piece you're talking about. And then make sense of the data you collect and decide, is it good or is it not good? In the design tent, we need you to complete that entire process. Okay, you may be able to go fast if you skip that part, and you may get a score on the dynamic area, but it's not going to happen in design, and it's not going to make you a good engineer, which ultimately is our goal here. So we'll talk more about validation a little bit later and a little bit about testing, but I think now, Tony, I think it's your turn to give some general guidelines.
Hey there. One more thing about the validation piece of it. We see a lot of models, a lot of simulation data, and it's kind of a bummer when we don't get to see some sort of validation or correlation to those models, because more often than not, all models are wrong, some are useful. So it makes sense to take that model, do some physical testing with it, try to make that model more accurate, go back and tweak it a little bit, make it more accurate, so that you can then iterate on that model and have confidence in it that it's going to better relate to the overall outcome. So one more little tidbit on the validation piece. Okay, for those of you that were here last year, these next couple of slides are going to be, basically very similar to what we showed last year. I think the key here is that a lot of these things are relatively timeless, at least hopefully they are. General design process, again, starting point. You need an overall plan. You need to have that plan, that strategy based on something. We recommend, given the rules, a good read. If every team member hasn't read the rules, we need to correct that, because that's ultimately what's defining kind of what the vehicle needs to be, what it needs to do. Tires, you've only got 4 little contact patches on the ground. That's what's applying all your effort that you're putting into your cars into actually making it go. So we probably should spend some time looking at the tires and giving that some level of priority. Scores. A significant number of teams are doing a really good job of basically looking at their overall goals for what they want to accomplish in the competition, breaking that down into points, and then trying to assess value to different attributes of their vehicle, and giving weighting different aspects of it in order to help, again, maximize their overall score. Lessons learned. Again, why relearn something when the year before you, 2 years before you, 10 years before you, a lot of teams that have been going for a while have got some documentation. Man, you should really spend some time looking at at some of that old documentation and see what you can glean from it and then apply. Again, instead of having to reinvent the wheel, just look at the wheels you've already had, got some documentation for, and really pull that together. This is one of the areas I think where last year, we've kind of seen more of a delta in terms of, it appears as though teams aren't doing quite as good of a job of transferring knowledge onto future teams, which is kind of a shame because, I'm sure all the hard work that you guys have done in order to get where you are. It's going to be kind of a bummer if you were to come back to your university, say 3 years from now, and you see some an active team there working on the same problems that you solved, and it'd be like, wait, I wrote that down. Why didn't you just, instead of redoing my work, you could have been taking my results and then doing something, taking it to the next level, kind of a situation. So I think there's a lot of importance on documenting things well, transferring the knowledge, and hopefully, ultimately, that builds into, your team basically becoming the starting point for one of the legendary, long-lasting, legacy. It could be like the future legacy. All right, I already talked a little bit on the per event point deal. Performance specs. Again, a lot of teams really want to jump right to the answer. I think it's very important to start very, very high level, set those highest level goals, and then you start breaking the vehicle down, breaking the outputs that you need to accomplish those goals, piece by piece. Before you specify the engine, you should be looking at what do I need for an acceleration, performance, then start looking at what things might get you there. Breaking the car down and, from, start high level, break the car down into systems, and hopefully everything is relating back to that big picture. Ultimately it's a system of systems, and it doesn't matter how great any individual system is optimized, you need the whole thing to be working well. And sometimes you may intentionally want to, degrade the potential for one system in order to make the whole vehicle ultimately, better. CG, overall mass. We already talked about mass a couple times. I won't go into, well, I guess I'll mention it a couple times later, but having a good idea for what is your target weight distribution. There should, the basic physics here, mass, and where that mass is, are absolutely critical to any, basically it's involved in every aspect of the, vehicle dynamics. So you need to set a target and then fight like heck to make, to hit that target. And if for whatever reason you're not, there's probably some, again, big picture level changes that you need to make in order to account for that. If your weight distribution front to rear is off, well, we may have to play with spring rates. We may have to play, do some stuff with aero. We may have to do some stuff with dampers. We may have to do some things to account for that in order to, get back to that original high-level goal that I set. Synthesis, again, every piece has a role to play. You need to make sure all those pieces are playing well together. I already mentioned the weight distribution. Then integrating through systems integration issues. There's a tendency to design it and then build it and then let's test. This is a very iterative process. Ideally, as you're developing your vehicle, you are learning things, and you may learn that, hey, this decision, maybe it wasn't ideal. What can we do to iterate and make it better? I know it's hard for a lot of teams to get cars built early, but this is one of the important reasons for getting a car built early, is that you can A, start developing your drivers, B, figure out what's going to break, but C, you should be looking at the vehicle performance and the data that you're getting, and then being able to get another design iteration, maybe even two, in order to better optimize the overall system. Considerations: keeping it simple versus high tech. We see a lot of teams really trying hard to earn design points by adding complexity and doing some really cool stuff. Definitely don't want to discourage teams from doing cool stuff. I mean, that goes without saying. But we also, a well designed, well thought out, well executed, but simple car can still really do well in design. And I don't think we've had like a true bare bones car win design in recent years. But that doesn't mean that it can't happen, and doesn't mean that it shouldn't happen. So, make sure you're managing your resources right, such that whatever you're trying to accomplish, you have the resources to do it. And it could be a situation where you do need to scale back some of the scope in order to better execute, the plan. Bill had mentioned, maybe the both, aero components. Is aero effective? It sure can be. But is it the right choice for every team? Maybe not. So again, think about that as you're looking at and assessing your resources and just how much do you want to bite off. Tire data. Edward actually had a very large part in the tire test consortium. I think most universities at this stage are a part of it. In addition to the access to tire data that, to be honest, as an engineer, I'm envious of the data that's available. I've contemplated several times buying in personally just so I could have access to the data myself. So if you're not using that data, I would highly recommend looking into it and give it consideration, because not only is the data there, but the group and the people chatting through the data on how to analyze it, how to utilize it. There's a lot of really good discussions happening there, and it not only gets you access to the data, but I think it helps you, gives you a good connection to some resources for how better to use it, and then just learn. Data acquisition. Don't forget about the driver. Obviously, there's no question that there's a lot of amateur drivers. On these teams. For most teams, I would expect that these cars are the fastest cars that they've driven up to that point in their life. For a lot of people, it's going to probably be the fastest car they ever drive in their life, just because there's so much performance here. And it's hard to drive these cars very well. So make sure you're not only just getting people seat time, but you're actually using the data as a tool, doing debriefs, talking through the results, making sure that the plots and the traces are matching the driver's impressions, and then some feedback should be happening there. Not only how do we make the car better, but if you did this, the car would perform better, kind of things. Mass versus stiffness. We do have a lot of conversations about, when talking about structural components, chassis, whatnot, about strength. But stiffness is also a huge factor. Often stiffness matters more than the actual strength. There's a lot of situations where the part will not break, and you've got all kinds of margin to a part failure, but it's not stiff enough to do the job. And this is particular particularly important, when we start talking about suspension components, the overall structure. And again, this goes back to setting good targets, and having those targets trickle down in individual component, specifications. Fuel, obviously there's some trade-offs to be had there. I won't go into any detail, but again, know why you're doing what you're doing, and hopefully that why again fits into your overall master plan. Itty bitty parts, masses versus reliability. It kind of goes without saying. Yes, we want the cars to be light, but you also have, there's a reliability aspect there. I don't think we saw any major. The reliability, I think, was pretty good this year in terms of like part components. We have had years where teams went crazy on the mass reduction, and in some cases went a little too far. Obviously this is where the validation and making sure you get the car done early enough to be able to drive it and develop it and find some of those things. We'd much rather have you find it a month before competition at your school, where you can then spin the design, rebuild some new parts, get it going again, drive it. Yep, we're good now. Come here. Versus, you learn out there the first time it really drives, and now you've lost points. Materials. Carbon fiber, yeah, it's cool. There's no question. That we all like, nice carbony bits. But make sure you're doing the, you're using the full design space. Make sure you're picking the right materials. Carbon's cool, but it isn't always the best material for every application. Especially when you start factoring in the overall team resources, the processing, the manufacturability, aspects of it. Sometimes, some simple, brake formed aluminum is enough to get the job done. You can put some holes in it. You can do some things, make it, still make it really light, but significantly more manufacturable. But again, it's the right material for the right job. Modeling and analysis versus physical testing. Again, I feel really strongly about the whole importance of the validation piece. Models are models, and ideally you're gonna be able to ground that model with real data, so that you can have high confidence in it, be able to iterate on it, and know that the end result is gonna match the what you intend to happen. And you can do this with taking a model and making a very simple version of it, prove that simple version out, physically, to at least make sure that the physics is right, and then you can add some complexity with basically controlling the amount of risk and controlling the very possible variability. Here's another situation here of design complexity. Two very, very different cars. I should offer up a prize if students can pick out what cars those are, but we won't do that. But again, it's just important to remember that that there are always trade-offs. Ideally, the more complex version may offer some additional paint, some additional performance, but it's going to be harder to make. It probably weighs a little bit more. It's definitely going to cost more. Make sure you're doing those trades, and make sure that you're coming up with good rationale, good practical, practical reasons and explanations for every aspect and every decision that you're making. Aero. Again, we saw a couple cars out running around today that did not have aero on, but they were tearing it up. There's definitely a lot of performance, opportunity. But again, just want to reinforce, especially for the smaller teams, that you don't have to have aero on your car in order to do well in the competition. If you look at the the leaderboard, there's it would appear as though there's definitely an indication that well executed, it's probably it could be better than not having something on your car. But again, it comes down to what's right for your team. Want to just encourage teams to do what they're going to do, still be able to justify their choices. Again, as it was mentioned earlier, that even if you don't have an aero package on your car, you should be able to explain why. You should be able to explain and say, we understand that it probably cost us this much in lap time. That's the trade-off we're willing to make. And these are the benefits. We saved mass, we saved cost, we saved resources. We only have this many people on the team. This is how we allocated them out. Again, support the overall decision. Is that the last one? Oh, composites. We've versus previous years, I think our number of composite tubs is actually down a bit, which I'm totally cool with. Again, it is very much like the wing thing. I want to make sure that teams are making decisions because they're the right decision for their team and not because it's what they think the design judges expect or want. In general terms, a car comes in, if it's got a carbon tub versus a space frame, I look at them exactly the same. It isn't like, oh, this one's got a carbon tub. Well, this one's better. I'm going to give it more points. It's very much, okay, this is where we're starting with. Okay, how what did you do? Why'd you do it? Let's talk through the execution. It really comes down more to what have you done, why have you done it, and that sort of a thing. I kind of list through some of the more challenging aspects of composites. Just again, they offset, which some of them offset the potential benefits. I don't know. Do you want to start hitting the button? There we go. The amount of mental horsepower we have here pushing the slide buttons is astounding. This is Zach Eakin over here. All right. Some things I think it's useful just to kind of think through and kind of just keep thinking through, as you're working on the cars. Good design, really honestly, if it looks right, it usually is. And the corollary there is that if you walk up to it and it just doesn't quite look right, it's like, is that right? Load paths, good load paths, efficiency saves you weight. Efficiency gives you reliability. Efficiency of load paths gives you, stiffness. This is one of those things, it's very, very fundamental, and I know we have, conversations, it's like, well, but we did that because of this, and there's admittedly, there is compromises to be made. There's a balance to be had, and we fully understand that, but ideally, we're trying to drive the fundamentals and have the fundamentals, what's right fundamentally just being like, that should be the first option. That's where you want to go, and understand, and then from there, you make some compromises. Triangles make, for stiff structures. Rectangles do not, unless they have a cross member, then they turns them into two triangles, and then they're good. Tetrahedrons, if that's your 3D triangle kind of a situation happening, and also nice and good and stiff, and makes us all, that's design judges all happy when we see them. The best part's no part. This is kind of funny. This is actually, I don't know, how many times a day do you think we hear this at SpaceX? I don't know, at least a dozen, I would guess. But I mean, the part that you don't put on the car, can't break, cost you nothing, takes you no time at all. You can just manufacture them by the billions, because they're so fast and easy to make. It can't fail, all kinds of good reasons. So this goes back to the simple design. If you can have one bracket that supports two parts, why would you build two brackets? It's kind of, really, again, going back to the very, very simple fundamentals and trying to make sure that you're, being as efficient as you can with your design. Systems engineering, know it, love it, live it. One of the complaints we get from some faculty advisors about how we do design judging and how we assign the points is that there's often a concern. It's like there's not enough emphasis on the overall system, on the whole. I tend to argue against that in that every one of, in addition to having a systems, category, that even the suspension system has elements of that. The powertrain system has elements of that, and it's really it should be continued all the way through the whole process. But again, I just can't overemphasize the importance of going back and considering the whole vehicle. The last thing we want you to do is start your design, start your program in the fall, break the team up in the systems. Everybody goes their separate way, designs up their stuff, even if they build cool kick-ass bits and pieces, and then come together and it's like, but it doesn't play together nicely, engines, engine calibration, super important, and then, I note there spark. I think spark's off to one of the things that, everyone talks about air fuel. Sometimes they, forget to, spend as much time maybe as they should, playing with timing and spark and that kind of thing. And I guess on that aspect, there's a number of teams that are also just chasing the best horsepower number they can find. But boy, drivability is pretty darn important out there. I don't know if it's really apparent when you see the cars on the track. Some of them, it's kind of like, are they driving it with a toggle switch? Did they have a throttle pedal or just a toggle switch? It's hard to tell. So make sure that you're spending time on the drivability aspects of it, because again, these cars are hard enough to drive as it is. One of the best tools you can give the driver is a good throttle control, good responsiveness. Mass, we hit it, but again, it's there, it's real. Want to hit me on the next? Things to ask during the design process. Does the car look like it was designed with system focus? Again, a little bit repetitive, but you get the point. What parts look like afterthoughts? For me, this is one of the ones that really kind of gets me. I walk up and it's like, that wasn't intended to have been there. That was oh crap, we have to put this on the car somewhere. I guess we can put it here. Make sure you're fully thinking out the whole vehicle. I know there's a lot of anxiousness. We want to just build our frame and get going. But make sure you think through the pieces, at least have an idea for where everything's going to go. It doesn't, not every little bit and piece has to be in CAD, but if you can, you should, but at least have an idea and a plan. Things, should be tidy and well packaged. Some teams, go so far as they'll make like little, they take cardboard and they make cardboard models and do a full mock-up with, PCV or PVC pipe and tape and cardboard just to kind of get a sense for where everything goes. Physically modeling it all up. I mean, it's all in CAD. You can spin the CAD and all that, but there's an element of, man, it's just I know exactly how far I can push things if I build up a little mock-up. It can be pretty useful. Wiring, again, this was touched on earlier. Man, there's a lot of cars here today that I swear it's like if you just give me an hour with some electrical tape and some zip ties, I can make a bunch of these wires just disappear. It's one of those things where, it not only does it just tidy things up, but it's going to keep things cleaner. Odds are it's going to make things a little more reliable. Wires don't like to be just, shaken and flexed and bent. Sooner or later you're going to have some fatigue issues or, something's going to bite you. You don't know where, you don't know what, but definitely encourage, just, again, spend some time to kind of tidy things up. The adjustability, we definitely had a couple of situations where, judges were walking through designs and found some things that were like, okay, so what do you do? It's like, to adjust this, we take this off, we take this off, we take this off, and then we can, then we can turn this bolt. It's like, ooh, that's not great, because, you want to maximum, you have limited, most teams have limited development time as it is. Make sure you're really thinking about how do we make this car easy to adjust. So car comes in, talk to the driver, download the data, okay, we need to add another 1/4 degree camber. And it's like, if you got, I've got a 1/4 degree camber shim here, I'll just loosen this bolt, slip it in, tighten it up, go. And even with high confidence, exactly what that change meant. You know what it did. There's a lot of little things like that you can do that are not that hard. Maybe it takes a little bit of cleverness, up front to put that provision in, but it can yield huge rewards down the road. And as a design judge, if you show us that kind of a thing that you've thought out and planned about how to do quick adjustability, we love that. We just eat that up because we've lived it. We know what it's like to, some of these things can be kind of painful without easy, quick fixes like that. Again, is the car on track to mass? If as you guys are building, the car, you don't have a mass tracker, what the car was designed to, and then here this brake caliper came in. I'm going to weigh it on a fish scale. I thought it was going to weigh 1.2 kilograms. Ooh, it's 1.1 kilograms. Okay, cool. I'm going to enter that number in. What did that do to my CG? What did that do to my weight distribution? You'd be tracking these things, and if something like, I'm going to put the battery on the left side of the car, and left side's this way, left side of the car, and the battery comes in and it's, half a kilo light or half a kilo heavy. It's like, well, now I'm heavy on one side or I'm light on one side. What can I do to fix that? To make sure that in the end, I'm hitting that target that I set, way back in the beginning. Tuning, I already kind of mentioned that, discrete adjustments. You want to be able to, optimize the car. Next. Packaging examples, pretty much there's a lot of stuff here you would not want to replicate, obviously. Next. How are we doing on time, by the way? You're good? All right. Again, some of these cars, you look at it and it's kind of like the wiring. It's like, where did they hide it? Where is it? It's like things are just so well thought out and well planned that a lot of the bits and pieces that would normally kind of look, just be dangling off, they just kind of just disappear. You know, they just kind of they have their place, and it just, you know, as a design judge, you walk up and it's almost like, oh, okay, this is nice. You know, you know, what impresses us is the stuff we don't see, not so much the stuff that we do. Yeah. Again, tidy with the details here. You know, while you guys are doing development, you might want to be, you might want to start off with like long threads. It's like we want to be able to throw wheel spacers in and play with the track with a little bit. Okay, yeah, that's cool. But by the time you come here, hopefully you know what you want your track width to be, and you've locked it down, and you no longer need it. Again, harping again on the wiring, brake lines, all plumbing stuff should be nicely routed, intentionally routed, not just, well, we had to go from here to here and we had some extra links, we just looped it around, or what have you. Just taking a care to, a lot of attention to the little tiny details. And again, a lot of these are things that you get here Wednesday night and you got, a couple hours, you could be fixing a lot of this stuff while you're here, Ideally, you're doing it back at home, but, some of this stuff does not take long to make small incremental improvements. Wing mounts. Wings falling off in endurance used to be a big problem. I think we've been in pretty good shape here, recent years. That said, there are definitely a lot of wings that are doing some dancing on the car. You also see a lot of teams where, they've added some structure, and it's pretty obvious that they've added some structure. So make sure that you're thinking through the all of the load cases as you're designing your wing mounts, in vehicle packaging. Oh, all right. Was this you? All right. We'll get Edward back up here.
Thanks, Tony. Thanks, Tony. We have just a few slides to go, and then we'll, I believe, have a short question and answer period. But I'm back to talk first about testing and development, and then a little bit about your document submissions. So first of all, testing and development. We talked about the engineering process, validation being essential. Okay, let's talk specifically about when you go test your car. Testing your car is expensive in many ways, whether it's monetarily expensive, time expensive, resource expensive. There's many ways it's expensive. So you need to optimize or just not waste at the minimum the time that you spend testing. So before you go out to test and drive the car, you should have a plan. Okay, we'll skip to the test plan first. What are you trying to do? If you're just bombing around going fast, making smoke, that's maybe fun, but you're not learning anything. Okay, so go with a test plan. Have some goals. Have outcomes that you're trying to achieve. What is the target of this test? Also, know who's doing what on the car. I mean, you should all have team members with certain assignments so that things don't get missed, so that everything gets done and you're in good shape. The car's going to run reliably, certainly more reliably, if you don't accidentally forget to check this or that or do a certain thing. When you take data, one data point is just a data point. It has context relative to other data points. So it's really good to have a baseline saying, I started here, I got these results, I changed this, it went in this direction, I changed this, it went in this direction. If you have the luxury of going back to the baseline later, that's a good thing to be able to do, and it may or may not match what you got the first time, and then you can scratch your head and say why and try to solve that problem. With all of these, with all the testing results you get, if you get an answer, it comes with more questions. Okay, that's the way this process works, and that's also known as learning, right? It's kind of like the higher you stand on a mountain, the farther you can see, and the more you can see that you haven't gotten to yet. It's the same way as you learn things through testing, analysis of your data, etc. Okay, so when you have your test plan, make sure you plan for a baseline, plan for different configurations, know what you're going to try, and then sometimes you want to put them in a certain order to make them easy to do. So taking a part off the car is less time than putting a part on the car. So maybe you want to start with a certain component on, and then rip it off, probably gently rip it off because you may want to put it back on, but take it off, do your next one. That's faster, it's a good use of your time. And then you're going to need a way to evaluate Did you make an improvement? Okay, this can be in many ways. It's not always just the stopwatch. Okay, I mean, it's driver feedback is important, even though we have largely amateur drivers, with almost no experience, and then other amateur drivers with some experience. You're not giving professional level feedback here in Formula SAE, but it's still very important. And the first thing the driver says is usually the most important thing to fix. That's probably a really good way to start. So in terms of who's doing what, somebody on your team, as soon as the car stops, should be there with a notepad or a laptop, listening to the driver and just furiously writing everything he or she says. Because that's the best feedback you're ever going to get, is that first dump right off. It says, it doesn't turn, and there's something poking me like down here in the seat that I just can't stand. Okay, you better fix those two things before you do anything else, and then you'll get better results from the rest of your test. Okay, so part of that test plan, let's go back up a little bit, should involve a setup sheet. Okay, this is not only what you're going to change, but what is the current configuration of the car? Hopefully you've scaled the car before you've gone testing, and do so every time so that you know your individual wheel weights, your front weight, left weight, cross weight, or diagonal weights. What components are on the car? What engine map are you using? Air pressures, just everything you can think of. That is a state of your car. Now, if you go out and test a certain thing, like maybe you have a different wing that you want to try, or wings off versus wing on, and you start with different static wheel loads, you're going to make a junk comparison, because now you've got something that you could have controlled and you haven't controlled it, and it's going to pollute your results. Okay, so testing is hard enough, and understanding the data you collect is hard enough. When you do manage to control all the things you can control, because there's still things you can't control, like the weather or the recent history of your test surface or what have you, control as many as you can, track them in a setup sheet, make sure that you're going out with the most accurately reproduced baseline car that you can every single time. Usually, your testing site is not right next to your shop, and so your packing list is rather important. How many of you have had the experience of driving 30, 40 minutes, whatever your testing site, and realizing you don't have something? Yeah, it's pretty common. Hopefully you make that mistake once, and hopefully you pass it on and see how long that lasts in your organization before somebody else at your school repeats that mistake and it's remembered again for a few years. Have a packing list, follow it. Don't go testing without something you need, and of course, don't ever test without the vehicle in a legal configuration with all your safety gear on, with the fire extinguisher nearby. Not doing so is just stupid, if nothing else, okay? That's really important. As far as data organization and management, different people are responsible for different things to collect. So when the car stops, maybe you have somebody that takes tire temperatures, probe temperatures, or air pressures. Somebody that plugs in and downloads from the onboard data logging system. Somebody, of course, that's talking to the driver and getting that initial dump of information. There's all sorts of things in terms of data collection, but there's also things that are just like vehicle maintenance. Who's looking out for the health of the vehicle? Just a common nut and bolt check before you go out for the next session. Look at your car. You should be able to spot when something is different or getting loose or such. Know your vehicle. And then, of course, data is great, but if you never look at it afterwards, it's meaningless. Okay? One of the things that we do here sometimes in design is that we have a 32-channel data logging system. Fantastic, that sounds great. Show me a plot. Okay, velocity versus time. Okay, show me another plot. Oh, that's all we look at. Yeah, okay, it's like, okay, so why do you have all these, you got to do something with it. You got to spend the time to actually look at the data, understand what, try to understand what it's telling you, try to learn something from it, and then you'll be able to come back to your next test with different test goals, with different intended learnings, criteria to evaluate, and you're just going to keep growing your process. Next slide. That is the secret keyword, by the way, that we agreed on ahead of time to get the next slide. Okay, switching gears to our required design submissions. Now, we all know that the design event ended at the end of finals judging last night, about 9 o'clock. Do you know when the design event starts? The design event starts, at least for this year, on April 3rd at 11:59 and 59 seconds p.m. Okay? The design event is the longest event in this entire competition. It runs for a good 7, almost 8 weeks. Okay? For most of that time, the only way we know anything about you is through the 3 documents you submit to us and us spying on you on Facebook. Okay? YouTube, social media, I mean, that's great for us design. Partly we're just curious and interested and excited to see how you're doing and what are we going to see? And we also kind of just want to see how you're doing and what are we going to see? So spying on you aside, your documents are incredibly important. We spend a fair amount of time looking at them. All of our design judges, I think to a person, take very seriously the reading of them, in carefully taking notes and being prepared to talk to you. So we have our design briefing, which allows you to show lots of graphs, pictures, etc., in a structured format. And when you write this, keep in mind your target audience. You are writing for professional industry engineers, so you don't have to explain terms to us. We know what a lambda sensor is. We know what Ackerman is. Okay, so just go. We will know what you're talking about. Okay, think of it as the resume for your car and your team. Okay. Certainly in a design briefing, we give you a part of the document early on to tell your team history. And when we say history, we mean long-term and short-term. It's great if your school has been participating in Formula SAE since the 1980s. You may be a new school. That's something good to tell us, first of all. But we also want to know that, last year, the team was a bunch of seniors and they all graduated and we're in a rebuilding year, or we've had a great group of people together for a few years and we're on a good trajectory and we think this is the year. You can tell us that your funding got cut. You can tell us that you had this amazing sponsor. Just what's your recent history as well, because nobody's starting from the same point. You're all solving the same problem with different constraints, and there's no way that's ever going to be equal, and that's okay. But we need to kind of know where you're coming from. That's influencing your design decisions. And if it's influencing your design decisions, we would like to know about it. It does give an overview of your work, of course. It's broken into sections which make it easier for us as design judges to get through your document. And when you're doing it, do be concise. We will have a chance to talk about all the most interesting bits during the design event. Now, something that's new this year in terms of the template is we exercised our right within the rules to assign penalty points for incorrectly formatted documents. Okay? The document itself, the design briefing, has page limits and a file size limit. The file size limit is 25 megabytes. It's hard to see up here on the screen, but it's white text on a blue box. And as you may know, all those little blue boxes are little hints to you to guide you in your writing of this document, what we're actually expecting to see in each section. Those just disappear when you're done with them. But it is there. Also, there are places where it says, like, hey, this section on suspension, 8 pages maximum. We have several of those. And we're always saying it's only this many pages. Okay, so if you add those all up, the maximum number of pages for this design briefing is 59 pages this year. Okay? We have about 20% of the field that have gone over that. And this causes a problem for us because now this may now be before your time, but the design briefing replaced a design report, which is a short 4-page text-written document which told us about your car. Did not give you the opportunity to show your work like we can now. I mean, this is way better for you as students to show what you've done, to give us insight into what we're going to see. It's just way more efficient document. However, the design report itself did have the advantage of if you wrote a 5th page, we just told our judges stop reading at page 4, and we kind of just went with it like that. Well, because we have a document that's now separated into different sections, we really don't want to tell whoever has the last section, it might be electrical or systems integration is the last one in this briefing, that tell our systems integration judge, just don't read that because it's beyond the page limit. And even when it was limited to 4 pages, we have lots of design judges who are like, yeah, but I don't want to be cut out. I want to do something good for the students. I'm going to read it anyway. And we have the same thing here. Our judges are going to read it if you submit a 100-page document when it's only supposed to be 59. And we don't want a benefit to be derived from some teams going over and presenting more information than they otherwise would have been able to fit into 59 pages. So this year we went with the option to apply penalties for extra pages. We didn't make it a strict right at 59 page. We within 10% over, we gave some leniency. We avoid the 1 and 2 page here or there, discussions. So if you were 65 pages or above, up to 89, we've applied a 5-point deduction. Okay, small, but we want to sort of stamp this out now with a small deduction and not have to go to bigger deductions in the future. If you were 90 pages and up, which is 150% of the maximum or over, then a 10-point deduction. And I think there were only, you'll see in the results how many of those there were. Not too many, thankfully. Our biggest one, I think, was 140-some pages, which was, yeah. Of course, in the days of the design report, we also had 140-page design reports submitted when you were allowed 4 pages occasionally. Don't understand. Anyway, for next year, okay, please be careful with the page limits. Let's not have to make this a bigger deal than it is. In fact, let's make this so that we start considering not penalizing for page limits just because everyone is following it and doing a good job. Next slide. Okay. The 2 other documents that we are asking for, one is a design spec sheet. Okay, that's really just the numbers that describe your car. Be as accurate as you can. Respect the units that are in the document. We are comparing these car to car. We expect to see a number in kilograms. When you put it in pounds, it throws us for a little bit. We understand your center of gravity is not 11.5 millimeters above the ground, but if it says millimeters and you put 11.5 in, well, who looks silly, right? Yeah, just please be respectful of the units. Don't do that. And be as accurate as you can. We understand the car's not completely built sometimes or not fully measured or tested when this document is due 8 weeks before competition. But just, give it your best and be prepared to explain the differences between your spec sheet and your car in the design event. As far as the 3 view drawings go, this is the other place we exercised our option to apply penalty points. The rules do require a top, side, and front views on individual pages, 3 separate pages. If you did that, there was no penalty. If you gave it on 3 separate pages, then if you didn't give it on 3 separate pages or you're missing views, then we just deducted 5 points. Again, a minimal, small number, but let's get your attention on this. Please stick to that. Give us 3 views on 3 pages, line drawings, not solid model renderings. It doesn't have to be done in a CAD system. You can hand draw it. We did have 1 hand-drawn one this year, which was fairly decent in some ways. It could have been better, but still, it's not bad in any way to hand draw these. People did engineering for the longest time, hand drawing their drawings, and there are still engineers to this day who successfully hand draw things. It's okay. Just a reminder, these document templates do change year to year. Sometimes they don't, but they can. So every year, start out with the assumption that you don't know what the template is. I have to go check what this year's template is, and then work from there. Make sure you're not getting caught out by using last year's. I mean, if you tried using last year's tax return forms to file this year's tax returns, it wouldn't go so well, right? So same thing here. Just make sure you have the current form, and you'll be in good shape. Okay, next slide. We have to talk about document submissions. Okay, we talked about when the deadline was for the start of the event, which was April 3rd at 11:59 and 59 seconds p.m. Okay, that deadline is at the 10 o'clock position on this pie graph. Let's start at the 12 o'clock position. In that first blue sector, we now have 6% of our field of competitors who handed in their design documents more than 24 hours early. Okay? So a full day before competition, we had 6% of the documents. Okay, now add in the red part. Now we're up to 1 hour before the deadline. We now have 31% of your documents. Let's add in the green part. We are now 10 minutes before the deadline. we have 50% of the field's documents. Then the denial of service attack begins. In purple, we have a 10-minute window where we received another 30% of your documents. And then we have 1 day late, and I very kindly left out the ones, I didn't separate out the ones that were a few minutes late, like 12:01, 12:03. We'll just lump them in kindly into 1 day late, which is another 13%, and then 7% after that. Why do you do this? This is not an optimization problem. Okay? There's nothing to be maximized by being closest to midnight or 11:59:59, because we're engineers. We gotta, Okay, so look, this is I make fun of it to get, to make a point. This is a deadline that is known 7-ish months in advance in concrete. Okay? There's nothing to be gained by leaving it to the last second. I strongly, strongly, strongly encourage you to make your own deadline for design documents, like a week before, 3 days before. Treat it like it is the drop-dead deadline that is posted. Okay, have your thrash if you're writing it at the last second. Okay, pound it out, and then when you're done, sleep on it for a day. Look at it the next day and see all the silly mistakes you made. Fix them. Your document will be that much better. Then calmly join the 6%. Okay? Grow that number. You can do it. Help us reach our goal. Really, you just get it in early. There's absolutely nothing to be gained by waiting for the last second. And you know what? If your power goes out, your internet goes bad, you find yourself in a late penalty, you've just, for no reason at all, lost 10 points or whatever, and it just doesn't make sense. So please stop doing that, and hopefully next year I don't have to have this kind of a chart. I mean, it was fun to present, but it's not the kind of discussion we want to have. Sure. Okay, I'm getting information now from reliable sources that they are ready to start the final ceremony, so we are going to skip our question and answer session and start getting to the awards. So everybody, thank you so much for attending this public design review. We appreciate all of you.
Buddy, you thought you were rid of me on Wednesday or Thursday, didn't you? I don't need the outside voice right now. I'm inside. Garages have big doors. This isn't the garage. Anyway, before we get started, while we're getting things set up, we have some housekeeping to do. We enjoy your company. We like you being here. You have a lovely habit of leaving us gifts. We don't really have the storage space. So very quickly, things that were left behind in tech inspection. Gear that we don't want. Is Missouri S&T still here? Hey, good news. I have this LECO gear. It's really good. You should bring it home with you and never bring it back to competition again. Send someone up here to get your stuff. Yeah, one of you. Yeah. Yep. Well, I got one more bag for you. Okay, we've got UC Berkeley. Anybody from UC Berkeley here? Our fine friends from California. I have gloves and a suit. These belong to you. OMP's nice. Okay, next school. If you are, car 81, Cal Poly Pomona. Cal Poly Pomona. It's a very nice suit. It's K&N branded. No? Okay, Cal Poly Pomona's a no. MSU, Michigan State. Anybody from Michigan State? Come on up. We got your shoes. 2 pairs of shoes. Good for weekends, not for competition. Here you go. All right, next. Temple. I think Temple's gone. Is Temple here? Anybody from Temple? Going once, going twice, sold. Saskatchewan. It says Saskatoon, but I think that means the University of Saskatchewan. Are you here? Okay. This is the Stoked Center. I have no idea what that is, but this is yours. Ready? Drexel. Anybody from Drexel? Drexel University. Nope. Okay. Colorado Mesa. Anyone from Colorado Mesa here? We got anybody from Colorado Mesa in town? Lovely city. Okay, great. Kentucky. Car 141, University of Kentucky. No. Georgia Tech. Come get your stuff. Yeah, we're all very proud of you. We know you're on site. Here's your stuff. We got gloves. Oh, first, University of Maryland. 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 Car 74. I haven't memorized the list, so. Car 74. If you were car 74, your gloves are over there. Car 99. Alpine Stars. They're nice. Akron, come get your stuff. You're killing me, Akron. All right. But wait, there's more. For just $5 more, you can add the leftovers in the lost and found box. Hey, do you have an active driver gearbox that doesn't have a lid? Who has an active driver gearbox? Do you have a passive driver gearbox? Inactive driver gearbox? Your lid's over there. See, I like bucket hats, and I that might fit me, but I already have one. Bucket hat, come get your bucket hat. It's a original gear top, UPF 50, original gear top. All right, not his. All right, last chance, gone. Wait, somebody waving in the back? Oh, they're waving to their friends. I don't want these stinky shoes that were together in Excel with a head sock. Did you lose your Nikes with your stinky head sock? The head sock is yours. So I get the shoes. You can keep the shoes, yes. They don't fit me. They're as old as me, but they don't fit me. Last chance. Fresh Nikes. It's a good fit. Okay, out. Don't bend it. No, hold on to it. There you go. All right, give me the fire bottle. Give me the fire bottle. Some of you are going to need these. You have a habit of leaving these for us, and I know that you need to have two, one in your paddock, one in your car. Somebody is short a fire bottle. Unfortunately, the name has been worn off of it. Okay, we'll leave it off on the side. This is you? Come get your fire bottle. Dr. Bob. All right. Oh, this is a sweet trucker hat, but I live in Michigan. I don't need to tell people I live in Michigan. Trucker hat says Michigan on it. Yes? No? In the bin. I think this one belongs to somebody from Washington University in St. Louis because it says Washington University in St. Louis on it in small serif print. I'm sorry? They left? Okay. Well, I'm not going to wear it, but it was very nice of them to leave me gifts. And see, now we're offering money for stuff. I like this crowd. I like this crowd a lot. Yeah, they know I have a race car to fund. Okay, I have a recluse jacket of some kind. It's got a spider on it. All right. Yes, no? All right. As I was told, bag of socks. Who wants the bag of socks? All right. Oh my, stop handing me socks. A bunch of socks. All right. Last few. Some tiny gloves with these are not, by the way, if you're coming to EV, these are not HV safe. High flex, rubber lined. No? Great. Keep going. Somebody's drill bit. Drill bit? Drill bit. I'll keep the drill bit. Oh, yeah, the size, because that would help. Because you've only lost one drill bit here. Well, the good news is somebody spun it in the chuck because the size is worn off. It's probably an 1/8 inch. Tighten your chuck better. Okay, Maximum. I think this is from Canadians, right? Maximum is the... Okay, Canadian teams, it's terrible that I know this is your brand. Maximum Flathead. Would Americans like to experience Canadian power? All right. The handle to a Volkswagen screwdriver. See, it's fun, the stuff you leave here. Oh, is that your screwdriver? Which one? The Volkswagen handle or the Canadian one? The Maximum, and it's a Canadian school, I guessed right. Hey, winner! All right, Cobalt channel locks. I'm violating trademark. Cobalt channel locks. Anybody? All right. No name linesmans. Anyone? All right, we got a few more. We've got some stuff that's actually quite interesting. Oh, somebody lost their cell phone at Excel, and I don't know if it fell out during the run. It's had a rough go, but I think it still works. Did anybody lose it? What color is it? Oh, it's a Samsung of some sort. Did you lose a Samsung? Bucket. Throw that away. These are, are these? I don't know what these are. These are position sensors of some kind or fittings. I don't know. Black anodized aluminum fittings. They're weird. Anybody lose black anodized aluminum fittings? There's probably threading in them. I'm not disassembling this on stage. Okay. Did you lose the key to your toolbox? I found this on Tuesday, and it's still here. R05 is the key code. There is literally no branding on it, otherwise I would have tried to find the team. No? In the box. Are you trying to get back into your hotel room? Oh, it's for the Container Store. Yeah, okay, so Town Place Suites. Who's staying at the Town Place Suites? No? You probably got another card. Okay. Hand me those. Okay, here's the fun thing about earpods is we'll match them up with whoever they are. Did anyone lose earpods? AirPods, sorry. I don't own Apple stuff. I don't know. Do they have the headphones in them? Well, I know, but okay. No, nobody's? The earphones are in them. If they're yours, we can match them up. All right. Last couple things. Probably your remote start, Viper remote start. Viper's old school. Okay. Oh, good. Old Sprite in a Boeing Hydro Flask. Old Sprite in a Boeing Hydro Flask, going once. Out. Okay. This was left at Excel, I know, because I've asked you about this. I have a question, though. I and several people have been asking, so you don't see it here, but the buttons are labeled go and don't. And I would like to know what don't means. Downshift. Don't means downshift in Missouri. I got tire blankets. Who wants tire blankets? I got tire blankets. I'm not going to tell you that, but possibly. I think there's 3. Will 3 get you there? Okay. They're patched up, though. They're lovely. Hey, they can go on your brand new Kaiser aluminum wheel with 16-inch. Whose wheel is this? I know you're running a 3-bolt hub. Did you lose this relatively scrubbed-in LC0 16 by... No? All right, calling it off. Maybe you run a 4-lug pattern and this is your wheel. Is this your wheel? God, it's heavy. Oh my God, no wonder 13s are out of fashion. Here you go. There you are. All right. Oh, these are stylish. Oh, I don't know. Not again. Do I have to do this again? Okay, I'm not going to put them on yet, but there are safety glasses, and there's sunglasses safety glasses. Are these your safety glasses? Were you welding in these or like grinding outside in these? Okay, I took my regular glasses off, so if you're waving your hand, I can't see. Sorry. And there's lovely tortoise... Sorry? Well, there's also lovely tortoise shell normal sunglasses, and I'm going to do something that I'm going to regret immediately. Let's take a show of hands. Safety glasses, sunglasses. Sunglasses? Sunglasses. Great, I'm going to be blind for the rest of this presentation. Anything else? Oh, never mind. All right. Don't boo the person who got there. No, do not boo this person. You are better than this. Probably. Okay, so safety glasses. The things I do for you people. I can't read this. Oh, there's a bunch of stuff that's still lost. I'm going to run through the list real quick in case you spotted it in your travels. First of all, I know the folks from Lakehead, and I'm not sure if they're still here. Someone on Lakehead lost a backpack which, among other things, included important documentation. If you found a black military-style backpack and you don't know where it goes, try to reach the folks at Lakehead University. I'm not sure if they're still on site. There's a white binder. Tate at Liberty U lost. An orange and blue wallet that goes somewhere, a blue notebook pad, Tyler at Cal State, and a Samsung Galaxy S22, which might be the thing that I just picked up out of the box. God, I hope that's not it, because it's in real rough shape. But hopefully they get their phone back. Okay, I believe that is it. So, I think it's time for some action. Thanks, everyone. In the future, please take your stuff with you. We don't have the space. All right. I think we're ready to go. I can't tell if we're streaming or not. I literally can't see further than this. Hold on. I have to change out real quick. I'm good. Oh, I've been doing this on the internet. Well, that's content. All right. As Formula SAE 2023 ends, SAE would like to recognize all of you for your dedication and hard work. You put a lot of effort into designing and building your vehicles, excellent vehicles. So I want you to give yourselves a big hand. We are so happy that you made it this week. We love putting these events on. It's your efforts that make these events challenging and valuable competitions. Hopefully you've learned a lot. We've enjoyed learning with you. We want to thank all the volunteers. It sometimes isn't always clear, but it takes over 400 people over the course of this week to make one of these events run. Some folks come for one day, some folks come for the whole week, some folks work beyond the hours. There are a few dozen dedicated volunteers who work almost year-round, reviewing safety documents, reviewing structural equivalency forms, preparing rule books, and things like this. So let's give the volunteers and organizers a big hand. Now, I want to ask a quick question, which is how many of you are graduating now or today or this week or... Okay, so a fair number of us who are here are going to be moving, hopefully, into exciting industry jobs. A lot of us volunteers are Formula SAE alums. All right, I raced at Rutgers. Folks have raced at lots of other schools. We come back here because we care about this program. We care about what it did for us and what we learned. We're here because we know how important this program is and how much it matters to you. So if you're a graduating senior or fifth year, whatever it is, please consider coming back to join us on the other side of the competition. If you're interested in signing up for volunteering for this event, for an EV event, for Baja, for any of the Collegiate Design Series events, Formula SAE Online has a link at the bottom of the page to sign up to volunteer for events. It's a lot of fun. It's so much more fun, and you get more sleep, I promise. Also, you've heard me talk about sponsors a lot today. We wouldn't be here if it wasn't for the support of our sponsors. They help us get resources that make this event possible. They come out here and talk to you about excellent opportunities. Without their monetary and people resources, the competitions that we have would not be what they are today. So I'd like to list them. They're alphabetical, but all of them are valued participants, valued parts of the Formula SAE family. So we'd like to thank American Honda, ANSYS, Bosch, Cummins, Dorman Products, DS SolidWorks, E-Controls, FEV, Ford Motor Company, GM, Hendrick, Hoosier, McLean Fogg, Magna, Mala, Mastercam, MathWorks, Multimatic, NCEES, Polaris, Rivian, Roush, Siemens, SpaceX, Stellantis, Sunoco, Tesla, and ZF. So let's give a big thanks to all our sponsors for helping us put these things together. Yeah. Hopefully you got a chance to meet them and converse with them because they're great folks and they make this possible. One last thing before I actually start doing the thing that you're all here to see me do. This stage is temporary. I know you're all excited. We are all just as excited as you are. But if you jump on the stage and you break the stage, we will bill you for the stage. We have you on video. We know where your university is, so please don't jump on the stage. Have a lot of fun. We're going to have some good photos, have a good time, but please let's not jump on the stage. Cool? All right. Good. Well, in that case, I suppose it's time for me to start helping to hand out some stuff. So, I'd like to begin with a trophy, an award that I think is a really great award. It's presented by someone who I know in my development as a Formula student was a huge inspiration. I learned a lot from conversations with him while I was an undergraduate. And the prize for the Learn and Compete Awards is the complete 2-volume set of Learn and Compete. I'll note that this book is full of essential information for improving your design, improving your process, improving your racing. It will make you a better engineer, so it's a great set of books. Many of the senior design judges have contributed to the development of these resources, so they're great books. Here to present the Learn and Compete Awards is Michael Royce. So big hand for Michael Royce. Can I have my spectacles? Thank you.
Good afternoon. Okay, these are the books. Volume 1, Volume 2. And these are presented based upon my whims to the teams that I figure have put in sufficient effort, but still need help. So the first team is car 67, UP Aguascalientes from Mexico.
Thank you, sir.
Next team is car 123, West Virginia. 123, West Virginia. Gone. Okay, they miss out. Number 59, Bradley. (109), Minnesota Duluth. Number 12, Purdue Northwest. It's obvious that these teams really need help, isn't it? Car 118, University of Georgia. '93, Wichita State. '79, and that's another Mexican school. Guadalajara. This is where I need my laptop because I'm on page 4 now. UMass Lowell, car number 132. '47, Liberty University. '41, UBC. No? Somebody's wearing a UBC sweatshirt there. Different one. Car 128, Universidad Autónoma Estado Mexico. Gone home. Texas Tech. Texas Tech. Lakehead. Lakehead. Car 69, Sherbrooke. Here's one that ought to know better. Car 25, Kettering. No? Car 90, Sacramento State. Car 24, Colorado State. Hey! Car 39, UCF. No? York College, Pennsylvania. Car 64, Saskatchewan. Car 30, Missouri State. Car 26, Cal State, Los Angeles. U of M, Dearborn. They've gone? University of North Texas, car number 102. 15, Lehigh. 46, Washington University, St. Louis. Nope. Car 108, Brown. Car 60, University of Hartford. Car 66, South Dakota State. I need two more, don't I? Car 98, University of Nebraska, Lincoln. Car 91, Texas Tech. Frankie, this is getting bad. One more. Car 49, University of North Florida. No, Alton, I'll give you the names and we'll arrange it, okay?
Okay, well, we'll make that happen for some of the teams who we hope to see here till the end of competition. As you know, staying here through Saturday is really important. You learn a lot, and we hope that everyone considers staying with us for the entire weekend in future years. Okay, next up, I'd like to invite up someone from General Motors to present their, it's not my award, to present their Everybody in Award. Mandy Damon is a chief engineer for battery electric truck at General Motors. Here to present the Everybody In Award, which comes with a check that you're going to have a really hard time fitting into an ATM. I can't see what's going on over here. You're just blurs to me. I'm sorry. Okay, great. They're approaching. Mandy.
All right. Good evening, everyone. Oh, good evening. All right. Way better. Thank you. My name is Mandy Damon. As you heard, I'm a vehicle chief engineer at GM. And it's an absolute honor to be here to present this award and this giant check to you. This is for the Everybody in Award. Just like each one of you, GM knows that the time that you spend engineering a race car with your team is immensely valuable. We've been there. We know what it takes. We know the kind of triumphs that go into building a multidisciplinary team, overcoming design challenges, and really coming together to compete in this world-class environment. I began my career at GM when I was 18 years old, and I now have the unique privilege of leading a team that's executing GM's incredible battery electric trucks. Like you, we're faced with unforeseen issues every single day that we must overcome. We're constantly finding ourselves railing as a team to solve complex technical issues, putting in long hours at the build site, challenging ourselves to continuously make the vehicle better, and constantly refreshing FedEx tracking information to figure out where that last part is. That was for Derek. Derek's been doing that for a couple months. It takes passion and it takes perseverance, and that, along with the hands-on engineering and leadership experience that you've gained, is exactly what sets you apart from the competition. We want to recognize what you and your team are doing to engineer the future. The Everybody In Award grew out of our desire to make meaningful connection with the students and teams while also sharing the values of our Everybody In campaign: safety, electrification, and social impact through inclusion. Embodying the spirit of Everybody In goes beyond just building a race car as a team. We envision that the team who receives the Everybody In Award demonstrates the following core behaviors: a pervasive safety culture, a commitment to reducing emissions by seeking out opportunities for efficiencies everywhere, and persistent good faith efforts to be inclusive of everyone in and around the Formula SAE community. We want to thank all the teams that submitted an application for the Everybody In Award. Only 7 teams submitted the application this year, and they are Kenowa State, North Carolina State University, Texas A&M, University of British Columbia at Vancouver, University of Waterloo, UP Aguascalientes, and Washington State University. This competition's winning team demonstrated their entire team's commitment to the pillars of Everybody In. This team embodies safety culture in everything they do, from instituting a designated safety captain to extending safety from their work and testing environments all the way through the disposal of scrap materials. The team embeds safety into their daily practices. Like GM, the team is also dedicated to a zero emissions future and is switching to the EV competition next year, even though this decision comes at a great cost to their team structure. Making the switch involves merging with an existing Formula SAE electric team at their university, which is effectively closing the chapter of team history to step into this new journey. And finally, one of the team's priorities is breaking down barriers to entry and engaging with their entire university community. The team facilitates new member engagement through training and have incorporated students from many different faculties and programs on campus. The team roster is over 50% persons of color, and over 1/3 of their general membership and leadership team are women. Most importantly, they have a reporting structure in place to address indecent and inappropriate behaviors and language to keep their team a welcoming environment for any and every student. That is exactly what the Everybody In Award is all about. It's my pleasure to announce the winner of the Everybody In Award is, should we do a drum roll? The University of Waterloo. Woo! Perfect. Congrats. Congrats, Waterloo. I'm gonna get in here with you. Awesome.
Thank you so much. Up next, we have another one of our sponsors to present a special award. I love this award because every year they bring really cool trophies. The Cummins Innovation Award is going to be presented by Derek Riddle. Derek is going to tell you a little bit about the trophies as he presents the award. Derek, come on up. Thanks, Derek.
All right, good evening, everyone. My name is Derek Riddle. I lead the Formula SAE involvement at Cummins. First off, just want to say congratulations to all the teams for making it here to competition. It was a really fun day today and all week. Cummins is really proud to support FSAE, and I know that I always look forward to this week every year. The Cummins Innovation Award recognizes innovative student work, both in powertrain along with all other parts of the vehicle. This year's prompts focused on cost-effective engineering solutions and necessary changes during the validation process that needed to be made as you all were building your vehicles. Like Alton mentioned, we have 3 awards to give away. I'm going to start with the 3rd place, which comes with a trophy that's made of a B 6.7-liter engine and $500. And this was for this team's cost-effective chassis torsion test rig and their dry sump validation process for 3rd place, North Carolina State University.
Thank you. Yep.
You're good? Oh, me back in? Okay. Check. All right, second place, $750 and a piston out of a 15-liter engine for their validation process to correct engine starter failures and their cost-efficient way to evaluate intake plenum volumes, Mississippi State University. Okay, first place, $1,000 and a trophy. This comes out of our 95-liter Hedgehog engine for their implementation of electronically adjustable brake bias, an innovative way to validate aero CFD on your car, the University of Pittsburgh.
Thank you, Derek, and thanks to our friends at Cummins for their support. Congratulations, winners. Now on to scored categories for the competition. We'll begin with the Business Presentation Award. As you all remember, you presented these things and prepared these things. The teams prepared a business case analysis for changing the power system, the prime mover in their vehicle, and presented this both in a preliminary round and some teams in a final round here at the event. So I have to bring my own wear, and now I can't see anything. Why did I wear these glasses? All right, I promise. Here we are. I know the stack now. Okay. In third place in the presentation event, the University of South Florida. All right. Second place in the business presentation category is the University of Illinois at Urbana-Champaign. All right. And now, for Formula SAE May 2023, your overall presentation event winner, Wroclaw University of Technology. Oh. Okay, big round of applause for all of our presentation event finalists and winners. Up next, the cost event. As you know, an important part of engineering is designing something that is affordable for your end users. The cost event asks you to validate your design's cost and present a case about why things are made the way they are. Let me get the trophy first. See, you make a guy who can't see put these glasses on. Okay, enough vision jokes. In third place in the cost event, Kennesaw State University. Congratulations, Kennesaw. Okay. In second place in the cost event, Universidad Metropolitana. Well done. And your overall cost winner, which is a combination of both design and consideration of the cost scenario. In first place in cost, California State University, Chico. Let's give another big round of applause as they're walking up here. Or I guess after they're up here. Cal State Chico, your overall winners in cost. All right, well done, everyone. Now, you probably came here from the design review, and so you're probably wondering how everything finished up. The design event is an important part of this competition, and all of you prepared reports describing the engineering decisions you made, how you validated, how you documented, and how you made important decisions about your vehicle. And so there were 3 finalists who rose to the top. In third place in design, Purdue University, West Lafayette. Congratulations, I'm one-handed today, so. In second place in design, he shuffles his papers, Wroclaw University of Technology. done, everyone. I'll let you get on. Congratulations. And in first place, the overall winner of the design competition, University of Illinois at Urbana-Champaign. Seriously, anybody can come up. There you are. How's it going? Congratulations. Well, there you go. Well done. In sometimes testing conditions, the acceleration event asks you to demonstrate your vehicle's ability to attain speed as quickly as possible. And I think that a lot of us had fun in the acceleration event, but some of us were a little bit faster than others, and that's okay. In third place in acceleration, the University of Illinois at Urbana-Champaign. Well done. Way to go fast. Second place in acceleration was also very fast. Shocker. Second place in acceleration is Wroclaw University of Technology. Thank you very much, sir. Congratulations. 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 I'm going to go off the stage because there's a lot of you. Now, some are fast, but one was fastest. Your overall winner in acceleration for Formula SAE May 2023 is the University of Connecticut. There you go. Congratulations. Going fast in one direction is good. Going fast in both directions is also good. The skid pad event asked you to demonstrate your vehicle's ability to obtain maximum lateral Gs. And in this event, a lot of cars were very fast, but 3 of them rose to the top. Third place in skid pad is the University of Akron. Well done. Always with the short. All right. Your second place finisher in skid pad is the University of Missouri. Well done. Congratulations. But first place overall in skid pad for Formula SAE May 2023, Missouri S&T. Congratulations. Congratulations. There we are. Okay. So yesterday you got to demonstrate your vehicle's ability to do the thing it's primarily designed to do, which is to be a great autocross vehicle. You sent your drivers out on the course to perform some autocross runs, and among all the teams, 3 of them rose to the top. So, for the autocross event, your third place finisher is the University of Minnesota Twin Cities. I can't tell. Well done. Your second place finisher in autocross, also a very good time, a very impressive car. The University of California at Berkeley. Congratulations. Congratulations. Everybody move back. This is going to be a big one. All right. Okay, easy. Do not jump. Well done. That's a long, close ride back to California there. All right. But one team in autocross was just a little bit faster than everyone else. So, your overall winner for autocross for Formula SAE May 2023 is the University of Texas at Arlington. Now, as you all may have noticed, the autocross run serves two purposes. It lets us see how fast your cars are, and it sets the order for the two big events, the endurance event and the efficiency event, the crown jewels of our competition, which we held today. Here to present the trophies for both the endurance event and the fuel efficiency event, which are presented by Ford Motor Company, is a representative from Ford Performance, someone I've known for quite a long time, Mike Bastanipour. Thanks, Mike.
Good pronunciation.
It looks like endurance there, efficiency there. I don't know why the guy who can't see is telling him where the trophies are. So we'll begin with the endurance event. You all designed vehicles that are supposed to be good weekend race cars, which means they have to last. And so you went out there today and you demonstrated that your cars can last. In the endurance event, a lot of teams did a great job and made it the distance, but 3 rose to the top. In third place in endurance, the University of North Carolina at Charlotte. Oh, he's just peeking. Yeah. They're staying in Toledo tonight, so they're not. We will mail the trophy. I haven't said that yet this event, have I? All right, the trophy's in the mail. Well done, North Carolina. In second place, Purdue University, West Lafayette. It's polite to shake hands. There's a lot of them. All right, well done. To you, sir. However, one team did the distance faster than everyone else when accounting for penalties and all that stuff. So, your overall winner of endurance for Formula SAE 2023, the University of Texas, Arlington. However, as engineers, we know that performance is important and efficiency is also important. And so remember that that event has two components. Ford is also proud to present the Efficiency Awards. And the teams that finish at the top of efficiency are sometimes the teams that finish towards the top of endurance and sometimes not. So, in third place in overall efficiency for the endurance run, the University of California at San Diego. Going up. Get your photos. So many of them. Well done to them. Second place in efficiency is a team that combined both speed and efficiency. Second place in efficiency goes to the University of North Carolina at Charlotte. We'll need a bigger box. Well done to them. But your overall most efficient vehicle in the endurance run is the team from South Dakota State University. Thank you, Mike. Thank you, Ford, and thank you, Ford Performance. All right, it's time for the big ones. There are 10 cups up here. So, we have 10 teams to call up. The 10 teams who, across all of the categories, combined all aspects of this competition to produce the best overall scores. That's why we call it the spirit of excellence. It's a broad categorical measure of success. As I call you up, you'll get your trophy, take your photo, enjoy the moment. In 10th place, in the Spirit of Excellence Overall Award, the University of California, Los Angeles. Our 9th place overall finisher is the University of North Carolina, Charlotte. Again, if you're watching, we'll send you the trophy, we promise. Well done to them. In 8th place overall, team that combined good scores across a variety of events, Purdue University, West Lafayette. Who gets the iron? There you go. Sorry, I lost my place. In 7th place, again, a team that finished strong in a variety of events, Georgia Institute of Technology, Georgia Tech. No jumping. Congratulations. In 6th place, a team that we've heard from this week, did a great job across all the events, Cal Poly San Luis Obispo. You want it? You want it? Yeah. Take it. Well done. Let's go. You're stop. Hold on. Help him up. There you go. Yep. Great. Keep careful. Carefuling. Carefuling. Great job. Great job. Okay. Before we move to the 5th place finisher overall, some final reminders. The chairs you're sitting in, They're comfy. They take a long time to set up. If you would help us by folding up your chair, bringing it to the back of the paddock or the back of the tent. See, my brain's still on paddock stuff, sorry. Follow the instructions of the staff. Stack them up nicely on the chair racks. I can't see where they are, but please help us clean up quickly by folding and stacking your chairs. Okay, business over. Back to the fun. In 5th place overall, strong finishes in some events. Really well done. University of Texas, Arlington. Thanks, everyone. I promise this is the final time I will say this week. Please, any trash left in your paddocks, take the trash, put it in the bag, tie up the bag, put it at the end of your paddock on the number. Please help us keep this place clean. It helps us use MIS. It helps make this event run. Help us out. Before you leave, clean up your paddock. If you need bags, we have more bags somewhere. Sound good? Do you want to hear more awards? All right, good. In 4th place, overall, the University of California at San Diego. Who's taking it? Are you taking it? Who wants it? There you go. John, good job. Good job, everyone. One more thing, although there aren't that many left, but if you need a box for your award, we have boxes for your award. So if you've won something, let the SAE staff know. We can give you some boxes for your awards. And speaking of awards, it's time to award the 3rd place trophy. Now, these are rather large. I'm going to try not to do anything untoward. I got to work on my arms. In 3rd place overall, your 3rd place overall winner is The Ohio State University. Okay. I mean, maybe I'll take that one home. Since we're talking about results, just a quick reminder, final results will be posted next week. You will get an announcement on the app. Look for the app push. So if you want to see the absolute final results, check the app for an announcement for the finals. Sound good? Within those final results, you'll learn of your 2nd place overall finisher. 2nd place overall for Formula SAE 2023 is Wroclaw University of Technology. Congratulations. Hey! No jumping. Okay. One final interrupting reminder. Actually, it's less of a reminder and more of a, well, it's a message from us. So the first thing is we hope to see all of you back here in May, whether it means you're back here competing, you're back here volunteering. We want you back here participating. We hope you had a great time. We hope you had a lot of fun this week. Please bring the good weather for another year. But we hope we see you back here in May for another Formula SAE competition. Most importantly, please get home safely. We want to see you here next year, okay? All right. I guess in that case, there's really only one thing left for me to do, and that's to hand out the big one. Now, I don't trust myself handling this with one hand, but here we are. If I break it, I guess I owe them the $2 that everyone wants to pay for the trophies. I'm kidding. This one's a big one. The vehicle and the team that win first place overall demonstrate competency and excellence in a variety of areas. It's not just one event that wins you this one. You get points in all of them, you do well in all of them. Your overall winner for Formula SAE 2023 is the University of Illinois Urbana-Champaign. To go around. Well, that's all we've got. No more announcements, except to say thank you all for coming. Please pack up your chairs. We hope to see you all here next year. Have fun, be safe, get some testing in. We'll see you all in 2024.